Hi, geometry students. In this video, we're going to continue with some triangle inequalities. So remember, the first triangle inequality theorem we learned said that the sum of any two sides of a triangle must be greater than the third side. Let's go ahead and solve some problems where our side lengths contain variables. So what we're going to have to do is we're going to have to write three inequalities because we don't know which side is the longest or the shortest. So in each case, we're going to add two sides together, and that sum is going to be greater than the third side. Let's start by adding together the two sides that I wrote in or highlighted in purple. So 3x minus 2 plus x plus 2 must be greater than 8 minus x. We can go ahead and solve that inequality by combining like terms. So 4x is greater than 8 minus x. Adding x to both sides tells us that 5x is greater than 8. Divide both sides by 5. And our first set of sides tells us that x is greater than 1.6. Now remember, this has to apply to any two sides. So this time I've remarked ours. We're going to add the two that I've now marked in green and compare it to the third side. 8 minus x plus x plus 2 must be greater than 3x minus 2. Simplifying on the left, our x terms cancel out. So we have 10 is greater than 3x minus 2. We're going to add 2 to both sides. 12 is greater than 3x. Dividing that by 3 means that 4 is greater than x. Okay, check to see which ones we haven't paired together yet. Well, I haven't added 3x minus 2 with x minus 8. So 3x minus 2 plus 8 minus x is greater than x plus 2. So 2x plus 6 is greater than x plus 2. Move our x's together and our numbers to the other side, and x would be greater than negative 4. Now remember, this has to be true for all three inequalities, so we're going to have to graph them and see where they overlap. So our first inequality, x is greater than 1.6, so I put an open circle about 1.6 and shade it to the right. Then I have 4 is greater than x. So 4 is greater than x would mean I would shade to the left. And then finally, my last one is x is greater than negative 4. Negative 4 would be somewhere off of my graph. But the key thing is all three of these need to be true. So we can tell that it's this interval here. So my requirements for x is my lower boundary was 1.6. So 1.6 is less than x, but x has to be less than 4. A second inequality we learned is the side angle relationship. And this says that in a triangle, the largest angle is across from the longest side, and the smallest angle is across from the smallest side. So in this problem, we're told that angle S is 80 degrees and that QS is the longest side. We want to figure out a range of values for angle R. If my longest side is QS, then that means that R has to be my biggest angle. Well, I already know that I have an 80-degree angle here. So R has to be greater than 80 degrees. Now you might think, because R is the biggest angle, that there might not be a lower bound for it. However, think about the fact that we know the three angles in a triangle. It has a sum of 180. So obviously R cannot be something big like 200. So if R was 100, that would give us a total of 180, and we won't have any left for Q. So R has to be less than 100. So we can write this inequality as 80 is less than R, which is less than 100. Now, both of the theorems we just worked with were based only in one triangle. This Hinge theorem compares two triangles. So the Hinge theorem says if two sides of one triangle are congruent to two sides of another triangle, then the angle between those sides in the first triangle determines the angle between those sides determines which third side is longer. Let's look at a picture and see if we can figure this out. So notice in this triangle, I have two sides that are marked equal. So AC is marked equal to CB. And then I also have that shared side. So TC is equal in both triangles. Now this is called a hinge because imagine that that angle where those two sides meet is adjusting. It's going to determine the length of AT and BT. Well, I notice that the top triangle has the bigger angle. So since that angle is bigger, it's also going to have the bigger side. So in this case, AT is going to be bigger than BT. Let's do a Hinge theorem problem that involves algebra. So if we look at this picture, first off, let's figure out why we can use the Hinge theorem. I have two triangles, and both triangles have a side labeled 12. And again, they both share a side that overlaps. So in these triangles, there are two pairs of equal sides. Okay, so we have a hinge. It's kind of set up odd. So let's think what that would let us compare. That's going to let us compare the other two sides. Okay, so we can compare JT and PE. Now remember, you can't always just go by the sketch. We have to look at that angle. We'll notice that the 45-degree angle is smaller, so that opposite side must be smaller. So x plus 3 needs to be less than 3x plus 1. And that's because the 3x plus 1 is across from the 115-degree angle. So now we're going to solve for x. We're going to combine our x's on that side. So 3 is going to be less than 2x plus 1. So 2 is going to be less than 2x. Dividing by 2, 1 is less than x.